Have you ever stopped to wonder how an app seems to, think? How it decides what to show you or what to do next? Well, that's exactly what we're going to dig into today. The simple but super powerful logic that lets our software make choices.
I mean, think about it. You open up an app, and in the morning it says, "Good morning." Later that night, it says, "Good evening." It feels kind of smart, right? But it's not magic. The app is just making a decision based on one piece of information, the time of day. So how does it actually pull that off?
Well, all of that seemingly intelligent behavior, it really just boils down to the program asking a bunch of simple, direct yes or no questions. And that fundamental process, that simple Q&A, is what gives all software its incredible power and flexibility.
So, where do we start? How does a program ask its very first question? It all begins with the if statement. This is ground zero for all decision-making in your code. It's the very first crossroad your program is ever going to see. And you know what's so cool about this? It's how much Python's logic is just like our own. In English, we'd say if the weather is rainy. And in Python, look at that, the code is almost exactly the same. It's just a slightly more structured way of saying what you were already thinking, which honestly makes it so much easier to pick up.
Think of an if statement like a bouncer at a club. It has one job: check the condition. Is the weather rainy? Is the time before noon? If and only if the answer is true, the rope drops, the gate opens, and a specific chunk of code gets to run. But if the answer is false, nope, that code gets skipped completely. The program just moves right along.
Okay, so that brings up a pretty obvious question, right? What happens when the answer is no? What if the bouncer says, "You're not on the list"? Our program can't just throw its hands up and quit. It needs a plan B.
Exactly. We've told our program what to do if it is raining. Pack an umbrella. Great. But what if the sky is totally clear? We need to give it a different set of instructions for that situation. And that's where else comes into play.
So let's just walk through this for a second. When our condition, weather equals rainy, turns out to be true, the program dives right into that if block and runs the code inside. Then it's done. It totally ignores the else part. It made its choice and it's moving on.
Now, let's flip it. Let's say the condition is false. It is not raining. This time, the program skips the if block, like it's not even there, and jumps straight down to the else block. Else is basically your otherwise command. It's the default action for when that first if condition isn't met. So if it's not rainy, otherwise, the program tells you to wear sunglasses.
Okay, so if and else, they're awesome for two options. It's a simple fork in the road, yes or no, true or false. But let's be real, life is usually way more complicated than that, isn't it? What if you have 3 or 4 or even more possibilities you need to check?
Let's go back to our weather app. We can't just ask if it's rainy or not. We'd have to ask a series of questions. First, is it rainy? If the answer is no, okay, on to the next one. Is it sunny? If that's also a no, well, then we ask, is it snowy? This creates a whole chain of decisions, and for that, we need a special tool.
And that special tool is elif, which is really just short for else if. It's perfect for chaining questions together. The program checks the if. If that's false, it moves to the first elif. If that's false, it checks the next one, and so on down the line. But here's the most important part. The very instant it finds a condition that's true, it runs that code and then skips the entire rest of the chain. It found its answer and it's out.
All right, so now we have our 3 main tools. We've got if to kick things off with the first question. We've got elif to ask as many follow-up questions as we need. And we've got else as our final catch-all, just in case nothing else fits. So let's put them all together and build something practical. What we're going to build is a simple grading calculator. The logic is super straightforward. You give the program a number score, and based on that score, it spits out the correct letter grade. So a 95 should become an A, an 82 should become a B, and you get the idea. This is the perfect job for our new if-elif-else structure. So here's how that logic actually looks in code. First, we use if to check if the score is 90 or higher. If not, an elif checks if it's 80 or higher. Now pay attention, because this part is absolutely critical. The order matters. We have to check for the highest grades first and work our way down. Think about it. If we checked for a score above 70 before checking for a score above 90, a score of 95 would technically pass that test and get a C. And we definitely don't want that. So the sequence is everything. And that final else at the bottom, that's our safety net. If none of the other conditions are met, it just assigns an F.
It's clean, it's logical, and it's really efficient.
And honestly, that's pretty much it. With just those three keywords, if, elif, and else, you've just learned the absolute foundation of how to control a program's behavior. You can now guide it down all these different paths based on data or what a user does, anything really. This is the very heart of programming logic.
So the big takeaway here is that you're not just writing a straight-line to-do list for a computer anymore. You can now build these complex crossroads and decision trees right into your code. So the real question for you is, now that you have this power, what decisions are you going to empower your code to make?
Thanks for joining this explainer.